Before we talk specific probability, we're going to do learning objective B, which talks about listing out a sample space. So some vocabulary first would be this. What probability theory is, it's a branch of math that studies chance. And in that, you're going to have an experiment, and that's a situation that has several possible outcomes. What are the outcomes? That's another word for the result of the experiment. And then sample space is a set of possible outcomes of an experiment. And it depends on the reason for the experiment. So here we have four different experiments going on. One is flipping a coin. What does the sample space look like if you flip a coin? Well, you're either going to get heads or you're going to get tails. So the sample space entails two different items. How about tossing a six-sided die? It's a single die, so that sample space is going to look like 1, 2, 3, 4, 5, or 6. A third example would be, what if you're taking an antibiotic for a sore throat? Your possible sample spaces are it works or it doesn't work. And then the last one here is, what about picking an integer from 1 to 100? That sample space would be the number 1, 2, 3, continuing on up to 100, so 99, and then 100 would be all those values. Now this example tells us we're going to throw two six-sided die. One is red and one is green. And both numbers are recorded. List all possible outcomes of the experiment, and they're asking you how many outcomes are there. Well, I just want you to notice how, for dice theory, a good way to write out a sample space. Right here is our first die, and let's say that the first die was a 1. What are the possible options with that? Well, the second die could be a 1, 2, 3, 4, 5, or 6. So you see there's 6 options if the first die is a 1. Well, if the first die is a 2, you're going to have the same 1 through 6 options. You have another 6. If it's a 3, another 6. 4, same thing. 5 and 6, the same thing. So if you look at how many different options there are, we have 6, 12, 18, 24, 30, and 36. So there's a total of 36 options. A nice way to find that is knowing this. If you roll die 1, and then if you roll die 2, how many options are there? Well, in die 1, there's going to be 6 options. In die 2, there's 6 options. What you end up doing is you end up multiplying that so you can know that there's 36. This is helpful, especially when they ask you to list out the sample space. If you had to list this out on a test or a quiz, it would be a little tedious, but here's what you'd have to do. You'd say 1, 1, 1, 2, 1, 3, 1, 4, and you would continue on until the last group, 6, 5, and 6, 6. So you would have to list all 36, and all 36 of them are right here in front of us. In this example here, we toss a penny, a nickel, and a dime, and we record all the possible outcomes. This is a good example of list the sample space, how many are in the sample space. Well, let's think through it first, by the way. If I have a penny, a nickel, and a dime, a penny has 2 choices, heads or tails. The nickel does 2, and the dime does 2. I'll end up showing you that there's 8 different possible outcomes for this. So let's go ahead and do that. Let's assume that the penny is heads, and that the other 2 are tails. But what if the penny is heads? We could have tails and heads. We could have the first penny is heads again. We might have heads and tails. Or we could have heads and then have heads and heads on this one. So that's 4 options. According to this, there's going to be 4 more because we need 8. Well, this assumes that the penny is heads. We can have all these scenarios assuming now that the penny is tails. So if we do that, if we start out with the penny of tails, the other 2 could be tails, or tails and heads, or heads and tails, or we could have heads and heads. And that's a sample space of all 8.